Hi everyone, good afternoon. Let's wait for 5 minutes. Let's others. Then we start the class. I think I should start the class. Okay, I am sharing my screen. If please tell if is it visible or my hair is audible to everyone. Okay. Um, okay, I am sharing my screen. And is Please tell if any problem is there. Hi, okay, I'm starting the class. Okay, first I will start with a question. This is the question, I'm writing it here. Calculate aqua complex of lanthanide where the magnetic moment is 0. These are the options. Okay, to solve the question, we have to know the electronic configuration of these elements. First, I am writing it here for the cerium, lithium. Okay, 4f, 5d, and 6s. Here, all the cases here, 2 electrons is there in the s orbitals, and for lanthanum 1 and d is 1, 3, 0, 4, 1. Then here I am just writing the electronic configuration. For F, here it's having 5 electrons, D1, samarium 6 electrons, 1, 7 electron, 0, 7 electron, 1. And here all the cases 662. So, to calculate the magnetic moment of the lanthanide elements, so we have a general formula, mu equals to J plus 1. Here J designates the total angular momentum. Now we have to calculate where mu equals to 0. This is our question. Okay. Now now we have to know what is the value of G. G equals to 1 plus J plus 1. Sorry. Okay. Now I am writing what the things are. L is the total orbital angular momentum. Here S is the total spin angular momentum. Okay, and J equals to the total means L plus S to L minus S. So here we have to calculate. So what I told, this is the formula. So for when it will be 0, G can't be 0, because this is having one term, and this can't be negative. So G can't be 0. It has a explanation also, but I am not going there. So now we will calculate the value of okay, now I am 3 plus, this is having 4f4 6. This is our question. We have to see among them which is having the magnetic moment is 0. Okay. Now for here, six, 7, 4 electrons. Zero, minus 1, minus 2, minus 3. So here what will be the value of L? E plus 2 plus 1. This is 0. So 7. Sorry. Okay, then here L will be, if it's having okay, I'm writing it here. Will be 4f6. This electron 2, 3, 4, 5, 6 plus 3 plus 2 plus 1, 0, minus 1, minus 2, minus 3. L will be P plus, this is 1 electron, here 1 electron, 2 plus here 1 electron, 1 here 0 contribution. Sorry, here 1 minus 1 minus 2. So this will be 3, and S will be here 1, 2, 3, 4, 6 electrons, 6 by 2. So what is the value of J? L minus S. So 3 minus 3, it equals to 0. Here the we already got the answer. Here where, so what is the value of mu here? G, J into J plus 1. So its value is 0. J value is 0. Then it will be 0. So this will be our answer. Means these 3 plus, but the magnetic moment equals to 0. So this will be our answer. Anyone got it? Everyone got it? Okay, let me check it once. Okay, I'm presenting. Hopefully I am visible to everyone. 1 minute. Now I am moving to the next question. Sorry. Our next question is, okay, I am giving some complexes and we have to tell where the magnetic moment is greater than only spin only value. Okay, Sir already told in the class that the magnetic moment has two contribution for orbital contribution, the spin calculation, and he already discussed that what is the things are also important for contributing both the things. So here I am giving two various complexes, and we have to 1 minute, okay? I think sorry for the disturbance. Okay, here is the thing. Okay, I am giving few complexes, and we have to calculate where the orbital spin orbital contribution is there. In spin only value is not equal to the spin magnetic moment is not equal to the spin only value. It's greater than the spin only value. This is 2 plus chromium. Another complex is cobalt. Okay, so for the is not equal to the spin only value, means greater than the spin only value. Okay, now to know that, okay, I'm what things are important. So total magnetic moment is equals to coming from spin contribution and the orbital contribution. Okay, so or for when the orbital contribution is there, then sir already discussed in the class that asymmetric distribution of electron in the T2G set. If you not getting these things, please go to the class. Sir already discussed all these things to you, because this is the only the doubt clearing class. So I have to solve some questions based what sir told in the previous classes. If you have any doubt, you please ask me. I will be happy to answer. Okay, then here for copper 2 D9 system, so T2G EG. Okay, so orbital unsymmetrical distribution electron is not there in the T2G set. So here it's not the greater than the spin only value, means it's not valid here. So in case of nickel complex, which is a nickel 2, this is a D8 system. So here we will see this is the d orbital splitting in octahedral field, as it is an octahedral complex. So there is no unsymmetrical distribution. This is also not valid here. Another one is chromium. Chromium 2 T4 system, T2G EG. Here also no. Another complex is cobalt, H2 whole 6 2 plus. D7 system. Now we will see the splitting of the d orbitals in octahedral field. Now I am filling the electrons in 4, 5. As all these complexes are high spin complexes, the water molecule is a not a strong field ligand. So all complexes, this is very important to know, these all complexes are high spin. It depends whether which is the ligand is coordinated with the metal center and the oxidation state of the metal. All these things are already discussed. I'm not going into details. Here we can see that the T2G set unsymmetrical distribution of electron is there in the T2G set. Okay, triplet degenerate. So this will be here the orbital contribution will be there. Is there in the magnetic moment calculation. Okay. Hopefully you get it. If you have any doubt, you can ask me here. So this will be your answer. Now the next question. 1 minute. Now the next question is I am giving these questions are from all competitive exams. If you see in the net questions and previous year net questions, you will get, or net or get questions. This type of questions usually comes in, actually 4 marks question it usually comes. These things we have to calculate the, for these complexes we have to calculate the magnetic moment. And we have to 1B, A, B, C, and this is D. And we have to arrange them in a ascending order. Okay, magnetic moment only the spin only value. Here there is no contribution. Here they are telling the there is, we don't have to consider any orbital contribution. Only spin contribution we have to calculate. Okay. Now I'm writing it here, every complexes. So titanium is T oxidation state, and titanium 3 means D1 system. Now let's draw the T2G state and EG state, and 1 electron is there, it will be in the T2G state. So what is the magnetic moment is the, this is the formula, n plus 2 Bohr magneton. So here 1 unpaired electron is there, n equals to 1 into 3. So it is root 3. Okay. For complex 1, complex 2, chromium 3, okay, D3, so here 3 unpaired electrons are there. So what will be the magnetic moment? 1 minute. I have to add some slides here. Okay, where is we? Okay, the magnetic moment will be, so here 3 unpaired electrons are there, so n equals to 3 here, 5, 15 Bohr magneton. Okay, then for the complex 3, what was our complex? Oh sorry, Mn will be 3 oxidation state, so it's having 4 electrons. Now T2G set, EG set, 4 electrons, these are the high spin complexes, 4, 3, 4. So it's having 4 unpaired electrons, so here its magnetic moment will be, spin only magnetic moment, 4 into 4 plus 2 means 4 into 6 bm. Bohr magneton. Okay. Now for the next complex we will calculate. Please do with me. Hexafluoro 3 minus cobalt 3. Okay, it's having 6 electrons. Now we will fill it in the T2G set and EG set according to Pauling's principle. 3, 4, 5, 6, and it's a high spin complex. So it's having 4 unpaired electrons. Okay, you can see it's having 1, 2, 3, 4 unpaired electrons. So it will be 4 into 4 plus 2, 24. Okay, I think I should here I should write the formula first. Only spin only. N into n plus 2. When the spin only contribution is there, then this is the formula. If you want to solve any kind of question related to this, then you can use this formula and can easily solve it. Okay, so here first complex 1 root 3 sorry root 3 and root 15, root 24 and root 24. What will be the maximum root complex C and D? So what will be the order? This will be the order. Okay. Did everyone got it, or if you have any question, you please ask me, because these type of questions are scoring questions. Uh, mm, Let me check it once. Okay, no question. Okay, then I'm moving to the next question. 4. But first I am giving you the question, then we will solve it step by step. Sorry, the copper. A copper complex having a distorted octagonal geometry. I am writing here questions also because that will be, if you see in the later classes, then if you want to watch the videos and try to learn, then you will also understand. Hopefully all these things will be helpful. If you have any suggestion, please share me in the text, or you can ask me. You can talk to Sarah also. Absorption band is here. This is the spin orbit coupling constant. They already, I think, introduced this concept. We have to calculate the wave effective in Bohr magneton. It's having 1.73, 1.81, 1.63, 1.93. Here the, now we have to solve it. Okay. Okay, now how to solve it? Any suggestion from anyone? Hello? Sir, already, at least can you tell me the equation? How to solve this question? Today wait or move? Hello? Anyone? No response. Okay. This is the equation. Using this we can solve the question. Sir already discussed all these things in the class. If my voice is also not audible, you can tell me. Hello. No one is responding actually. 1 minute. Hello. Am I audible? No one is responding. Okay, it's fine then. Then this is the equation by which we can calculate the equation. Here the question was, it shows the absorption band at 625 nanometer. Okay, and okay, other thing is the spin orbit coupling constant. Sorry. What is the value here? Minus 625 centimeter. Okay. Now we have to calculate the delta for this complex. Copper 2. This is a D9 system. Now I will draw the d orbital splitted to 2g and eg, and now I will fill the 9 electrons as it is a high spin complex 1 2 according to Pauling solution principle. Okay. Now now it's a d orbital 1 2 3 4 5. So 9 electrons we have to put. Okay. Plus 3 plus 2 plus 1. Plus 2 plus 1 0 minus 1 minus 2. So where the value of L minus 2, it will be 2. So symbol will be 2 and S will be half, and spin multiplicity will be 2s plus 1 equals to into half plus 1. 2. Spin multiplicity will be 2. Okay, now for T2, for this case the alpha value will be 2 for D. I also don't know why alpha for 2 say 2 is for D, but if you I can ask the sir and let you know in the next class. Am I audible to everyone? Okay, let me check it once. I'm audible now? Hello. Sorry? Audible, ma'am. Okay, thank you. Okay. Did you getting it, or if you have any problem? You have to join the class earlier, na, otherwise it's difficult to understand the things. Okay. Okay, now This is the formula. Spin mu spin equation is n into n plus 2 pm. This is due to the only spin contribution. How many unpaired electrons having? Only one unpaired electrons. So n equals to 1. Root 3 means 1.70 Bohr-Newton. Okay. Now next things we have to calculate the mu effective. Okay. Now I will put one by one. Here the values 1 minus alpha equals to 2, lambda minus 625 centimeter inverse. Here this is the hello. This is the spin orbit coupling constant value. The question is there, they already provided the spin orbit coupling constant and the absorption band. Absorption band is the nanometer they gave. So why it has to be in the same unit? Other, if you don't be in the same unit, okay, one thing, these things and this thing has to be similar, then it will deduct each other because it doesn't have any unit. So delta, this is the value of lambda. I am putting the value of lambda here, spin orbit coupling constant, this, and delta value will be, delta value they provided it 625. Okay, how they are calculated? So this is the absorption, means that it occurs due to the energy absorption from the lower energy to higher energy, means where the d orbital splitting happens, here the it occurs due to the electron transfer process. So here this will be the value of delta, means this is the crystal free stabilization energy, mean SCFE. So what will be the value? Its proportionality Hc by lambda. So its proportional to 1 by lambda. So del value will be 1 by lambda. Lambda means 6. They give 625 nanometer. Nanometer we have to put in the centimeter so that they will cancel each other. 10 to the power 7, nothing, no? 10 to the power 7 by 625 centimeter. 10 to the 7 by 625 centimeter inverse. This is the value of lambda here. Sorry. Now I am putting the values here. So it will be 10 to the power 7. Can you calculate it? What is the value of it? We know the value is the 1.73. This will be minus plus 25. Try to manage the units, then you can solve the answer or solve the question easily. So can calculate what will be the value? If not, then this will be 0.0078. 173 into 1.0078. Okay, now can you calculate now what will be the value? Sorry, this is Bohr unit will be. So from my side, I am getting it 1.864 Bohr magnitude. Are you also getting this thing? One is there. 1 minute. Hello. My audio. Hello.
Yes, ma'am.
Okay, I am audible, no?
Audible, ma'am. Audible, ma'am.
Okay, okay. If are you getting the things? If you are not getting, please tell me. Otherwise, it's because sir already discussed these things with in the class. I am solving the questions. Means if you not get anything, I can you please go through the lectures. You please go through the lectures, then you can solve the. Then if after that if you can't get, then you please ask me in this doubt clearing session. I'll try to solve them. Or if I can't do, then I will ask to them. Sorry. So okay. So what will be the value here? This will be, sorry. This will be our answer. This will be, this is close to the our calculated value, because this will be the our answer if they don't give any options. You have any questions? Or otherwise, then I will move with my questions. Okay, then the next question is 1 minute. Okay, I am giving few complexes. We have to tell which one is the diamagnetic and which one is the paramagnetic. Diamagnetic is where the means electrons are there, and the paramagnetic where there is a presence of unpaired electron in the system. So A2 and we have to calculate which one is diamagnetic or paramagnetic. Now the first complex, can you tell in which oxidation state nickel is there? Hello? In which oxidation state nickel is there? What is the oxidation state of the nickel?
It is not clear, ma'am.
What is the oxidation state of the nickel here?
Audio. I'm sorry, ma'am. Audio is not clear.
What will be the oxidation state of the nickel? I am not audible. You told that I am audible.
So audio it's not clear, ma'am.
It's not here. How it's not clear? Can you please check?
It's not.
It's clear? Yes or no?
Yes, ma'am. Yes, ma'am.
Okay. Then here the oxidation state of nickel is 4. This is the calculation. Let's consider its X, and fluoride contributes 6 minus 6, and total system is minus 2 meters. Here will be plus 4.
Yes.
Okay. For nickel 4, nickel 4, can you tell the about the complex? It will be high spin or low spin? Any idea?
Oh, yeah, ma'am.
Okay. Actually, nickel is +4 oxidation state. More means more oxidation state, more orbitals will be in interaction with the electrostatic interaction with the ligands. So beta splitting happens. That the difference between T2G and EG will be higher. If the difference is higher, the electron tries to feel the lower energy level first, because they always stress the lower energy. Then because for going to the higher energy it's needed more energy, so it will be a low spin complex. Did you get this? High spin, low spin, understandable, or I should tell you again? Okay. What I want to say, 6 fluid is there and nickel is +4 oxidation state. Crystal field theory, did you learn those things? Sir already discussed in the previous week classes. If you didn't read it, then you go through the lectures. Okay? Is it fine?
Yes, ma'am.
You go through the previous lectures. If you are not getting this,
Yes, it's clear. It's clear.
it's there, no? Okay. So it's having
Yes, yes.
this. So
Yes.
okay, this is the low spin complex. Okay, so what can I hear? There is an unpaired electron is there or not? What does it mean by unpaired electron?
All electrons are paired.
All electrons
It's
are.
a low spin complex.
That's why it's. My question is, which complex is diamagnetic and paramagnetic? Can you tell which it will be which type of complex?
Diamagnetic nature.
Yeah, that I want to.
Third means diamagnetic.
Yeah, nice. Diamagnetic complex. Then the next, what are the complex? 1 minute. Next complex was. Can you tell me what is the oxidation state of the cobalt here? Yeah, it's +3. +3. What will be the means electronic configuration means the outside electrons D. Do you know, or I can tell you how to do that?
Okay, I know.
Okay, you tell me what will be the how much electron D orbital having? D5. How telling it's D5? Cobalt, no oxidation state with a 0. What will be the configuration?
D6.
You please check the periodic table and tell me.
Sorry, ma'am.
You check the periodic table and tell me. I'm waiting for your and you joined at one question you have learned.
Audio, ma'am, audio is poor quality. I will be able to hear clearly.
Yeah, hello. Hello.
Yes, ma'am.
Yes, how much
Yes, yes. I can hear you.
Yeah, D is having how much electron it's having?
Yes, ma'am. Understand.
Okay. Can you check the period? I'm just asking for that. D is 2, D what?
Is 2.
4 is 2, 3D?
Yeah.
3D what? How much electron is there? Are you checking the periodic table?
No, ma'am.
You please check it.
Please, ma'am. You can.
Sorry?
No, sorry, ma'am.
You please check it. Now I'm waiting for
No,
that.
I am not having no periodic table, ma'am.
You can check the online. No.
27, ma'am.
No.
Ma'am, item number is 27. Right?
Yeah.
Over item number is 27, ma'am.
Yes. And what is the outer D? Okay, I should share the periodic table with you. I think 1 minute.
Therefore, 24.
Then tell me what is the how much electron it's having? 7 D. Sorry, I already told you. D. Okay. I can also help you. You told that 27. 18 electron plus 9 electrons. This is the inert gas configuration. Now you tell me what is the, what will be the value of D? What is number of electrons in D?
No idea, ma'am.
Okay, I think I should share the predictable. Then I think we'll get it. Okay, it will be 7.
18 plus 9.
7 plus 9 electrons.
This amount is 2. Oh, ma'am.
4 to the 7. Now, when you are removing 3 electrons, 1 electron will be removed from. This is the outer cell, no? 1 electron will be removed from here, and 1 electron will be removed from here. So,
This system.
D6 system. Did you get it?
Yes, ma'am. Got it.
Got it now? Now tell me how
Yes,
the
ma'am.
energy level is T2G and EG.
EG.
First of all, tell me, is this a low spin complex or high spin complex?
T2G. All 6 electrons will be lower.
Why you are
All
telling
6 electrons will be lower, ma'am.
6 electrons will be lower in
T2G,
there?
ma'am.
Why? This is a high spin complex.
Right complex.
Yeah.
It is high spin complex, ma'am.
This fluoride.
Right ligand, ma'am.
This is a fluoride is a weak field ligand.
Weak ligand.
So weak field ligand, it will be this energy difference.
Where is that? Yes, ma'am.
Pairing is due to the electron
Where is
arrangement.
that?
Weak field determines this value. Okay. Del value determines. So when weak field ligand is there, less interaction with the less electrostatic interaction will be the well center. So less interaction means this energy gap will be less.
Yes, ma'am.
So how the electron will be filled? D6 electron. If the energy gap is less, electron can easily 1, 2, 3, 4, 5, 6. It can be like that. If the energy gap is high, then it will go here, na? Okay, getting it?
Understood, ma'am.
Okay, now you tell me how much unpaired. Sorry?
4 unpaired electrons, ma'am.
Yeah, it is the paramagnetic compound. This.
Paramagnetic in nature.
Okay.
Yes, ma'am.
I think I should share the period with you. Then, if you have the electron, I think you are having some problem, no? Okay, it's already 6:57. If you have any question, then for my side it's done. If you have any question, then you can ask me here. Hello. Do you have any question or any doubt, or if you have question to solve here?
No doubt, ma'am.
Okay, then you get it now. What we learned today?
Yes, ma'am.
Okay. Then we'll meet in the next Saturday from 6 to 7. And please try to join in the around 6 o'clock because class starts. And if you join late, then you'll miss the okay.
Thank you, ma'am.
Okay. 1 minute. Okay. Thank you so much, and thanks for the kind attention. We'll meet in the next Saturday. Okay. Thank you.